Hello everyone. In the previous video we worked on problems 4, 5, 6, 7, 8. In this video we are working on chapter 10 problems and we're going to work on 9, 10, 11 and 12. In the previous video I do have professional microphone, but in the previous video it was recording through my tablet's microphone, so therefore you could hear whenever I wrote on the screen. I apologize for that, but in this video I hope it's been fixed. Okay, having said that, let's get started with question 9. So short-run production function was estimated. Okay, so we are given these coefficient estimates, A hat and B hat capital. At what level of labor usage does the maximum average product occur? Okay, so maximum of average product, right? Average product curve looks like this: average product, labor, and then you have quantity, right? We're trying to find this point, and maximum point of average product happens at the level of labor usage. The formula is right here, negative B over 2A. And what is this B and A? Okay, so let's write the cubic reduction function, short-run production function. Okay, so if we rewrite based on this, negative 0.02 L raised to power 3 plus 0.16 L raised to power 2. So this is your A, this is your B. Okay, let's find the labor minimum of the average product. Negative B, 0.16 divided by 2 times A. Okay, negative positive, you divide 0.16 divided by 0.04. If you calculate this, you're gonna find 40. The correct answer is C. Let's work on the next question. What's the total product when average product is its maximum level? So I only found that average product is at maximum when labor is 40 units. So when in English, when I hire 40 people, average product is at its maximum. It's not asking me average product, it's asking me total product. What is total product, folks? Total product is nothing but this Q, total level of output. Okay, negative 0.02, one more zero, I'm sorry, L raised to the power 3 plus 0.16 L raised to the power 2. Which L am I going to plug in? This L, 40 units. Okay, so it's going to be negative 0.002, 40 raised to the power 3. That means multiply 40 3 times by itself. 40 raised to the power 2. Again, I don't even use scientific calculators. I just multiply 40 by 3 times by itself. So this is 64,000 units. This is 1600. This multiplication, if you do this, it's negative 128 plus this comes out to 256. Cool. So the result, total product or Q, is going to be 128. So you're producing, when average product is its maximum level, you're producing 128 cars by using 40 workers. Okay, I'm just assuming we are producing cars. That's not bad, right? So break down the question, really read the question. Short-run production, question 11. Short-run production function was estimated, cool, the same question. At 20 units of labor, what is the average product? Okay, so I'm going to use the information. I'm going to plug this in at some point, but it's asking me average product. Average product is total product divided by labor. So on an average, total product. On an average, how many you are producing per worker? Okay, so I'm going to negative 0.002 L raised to power 3 plus 0.16 L squared divided by L. This is 2. It's going to be negative 0.002 L squared plus 0.16 L. And I'm going to plug in 20 when I see L. So let's see what we got. So this is 420 raised to the power to 400 times 0.0. So it's going to be negative 0.8 plus 20 times 0.16. This is found to be 3.2. So 3.2 minus 0.8, that's going to be 2.4. So correct answer is E. It's not too bad, right? Okay, question 12 is related to these. Let's get rid of this one. Okay. So in the short-run production function, same short-run production function, cubic form, at units of labor 60, what's the marginal product? Okay, cool. Marginal product of labor is defined as change in quantity, first derivative, with respect to labor when you change the labor by 1 unit. So I'm going to take the first derivative of this total product with respect to labor. So it's negative 0.002. This third power comes up front times 3L raised to the power, lower the power from 3 to 2, right? Plus 0.16 times the second power comes up front, 2. Labor raised to the power 2 minus 1, 1. So let's rewrite this. Negative 0.006 labor raised to the power 2 plus 0.32 L. Okay, we are not done. We are just going to plug in 60 whenever we see labor. Okay, so let's calculate. So this is going to be 3,600 times 0.006 negative. So it's going to be negative 21.6. Use your calculators. Plus, this is, if you do the multiplication, 19.2. So if you calculate this, you're going to find negative 2.4. Okay, so yes, marginal product can be negative. Don't forget that. That means the last worker you add actually doesn't add to your output, but it actually reduces. It's just overcrowded now. And that concludes this part, and I'll see you in the next video where we'll work on questions 14 through 18.